I'm recording now. Today's 11/9. You marveling at my composure? Today we learn finally about a better form of quadratic equations. It's called vertex form. I have never really addressed the other form with you directly, but I will today because it wouldn't have made sense before. But when you see the other form today, it becomes more meaningful when you give now the different forms a name. So the one that you've been working with to this point, um, for example, and you can write this, I guess write this down. If you saw something like y equals like 2x squared minus 5x plus 6, like if I sent you right now to make a graph of that, I have total faith that you guys could do this. You do your negative b over 2a, plug it back in, find your vertex, graph it, it goes upwards, right, at a rate of 2. Anyways, this form of equation, when you see it like this, like you're used to, I need you to know now officially that this is called standard form. What we're going to see today is going to look completely different, but believe it or not, it's exactly the same. So my first example will be dedicated to trying to get you convinced of that fact, that vertex form, while it may look completely new and weird, is actually just a rewritten version of the same equation. So anyways, this is what you'll see today. You'll see like y equals 1/2 times the quantity of x minus 4 squared plus 3. This has a name, and this, of course, as you can tell from the header at the top of the page, is called vertex form. And it's fantastic. It's marvelous. It makes graphing an absolute snap. So the trouble is that, so like today will be a breeze. Once we survive the first awkward like 7 or 8 minutes of this lecture, the rest is just smooth sailing. Like graphing in vertex form is cake. I could teach it in a 6th grade classroom. It's so easy. So we'll ask ourselves the question like, man, that's nice. Why can't all equations just be in vertex form? That's something you'll say to yourself in about 15 minutes. And the answer is, well, technically they can be. It's just sometimes hard to make them look that way. But that'll be part of what we do for a couple of days is turn standard form equations because they kind of suck into vertex form equations because they're really good. So anyways, that format that you see right there, that second one is called vertex form. And it might look like it doesn't have to look exactly like that. Like it could say this, y equals the negative of x plus 2 squared minus 10. That's, again, vertex form. It has a very characteristic look to it. Yeah, and honestly, there won't always be. I'm gonna keep my examples today, so there will be. But if that first number in parentheses was a 0, like if it said x plus 0, then we would omit the plus 0 and you wouldn't then see parentheses, but it would still be vertex form. So if you want to write this one down, you can. But like this is actually in vertex form. And to convince you of that, that would be the same as y equals 4 times like x minus 0 squared plus 3. Do you see that? So the parentheses will usually be there. Just know that if they're not, you could still make a case that they are. So that's what that is. All right. So to begin what we're doing here, and I don't even know if I want to go down this road, but something's telling me that I should. So I'm going to put an equation up here in standard form or vertex form, and we're gonna do some basic algebra 1 kind of skills and convert it into standard. And then we're going to do what we did yesterday and graph it. And I hope there's some payoff to this at the end where you kind of go, oh, that's kind of cool. So let's try this one. Let's do 2 times x minus 1 squared minus 3. Once I show you, if I didn't care so much about you, I would just show you right now, this is how you graph it. Go on your way, kids. Good luck. But I really want you to try today. Not all of you necessarily will want to, but if you do, I want you to be able to make the connection, like the legitimacy of like, wow, this actually is cool. This actually is related to what we've been doing. So in a moment, in about 5 minutes, I'm going to come back and we're going to graph this the easy way. For now, what I want to do is I want to actually just multiply this out. So forget about the y equals, and let's just do some basic algebra 1 math over on the right-hand side. So what we're going to do is we're going to expand this out and we're going to turn it into something that you're used to. And I may look back on this example and say, dude, why did you do that? But we'll find out. And you can give me a thumbs up or a thumbs down later on today. So what I'm going to do is I'm going to take 2 and I'm going to multiply out x minus 1 squared, which means to do x minus 1 times x minus 1. Nothing weird, right? At all. Now I need your help. Basic skills test here, peeps. I need your help with multiplying that problem. I'm terrible with this, the whole foiling multiplying thing. So I'm going to have 2 times. And then remember, you got to do the full 4-step process. You got to go x times x times -1, -1 times x, and -1 times -1. So we're going to get 4 answers inside these red parentheses. What's the first one? What's x times x? Good. And then I'll switch colors here to blue. What is x times -1? Negative x, good. And then I'll switch here to green. What is this -1 times this x, the little green guy? Yeah. Another negative x, and then the only color I have left, I think, is yellow. So let's do yellow guy. What's -1 times -1? +1, good. And then I'm going to shut down my parentheses, and then I'm going to tack the -3 onto the end. Like I said, I could look back. I've never actually started a lesson like this before. Something was telling me this could be cool if it clicks. So let's see. Let's combine and simplify what's in the red parentheses. So we're going to get 2 times, I hope you agree, x squared minus 2x plus 1. Right? Good. And then I'm going to tack the -3. Now it's time to distribute. What do we get? Distribute. Keep going. Good. And then I'm going to tack on the -3. And to put this in its final form, we're going to do 2x squared minus 4x minus 1. And then I'm going to bring back my y equals. So I feel good things coming, man. My vibes are still coming at me strong, positive here. So I'm hoping we're going a good place. So let's just go back, make believe now that all the stuff that happened in the last 3 minutes was not there, and that I gave you this problem. And I said, let's graph it. So we're going to graph this just like we did on last night's homework assignment. You're going to help me with this, with the basic skills. Can we just what, Gavin? Good job, bud. That's exactly what I did. And I say I've never in 27 years purposely done that before. I'm just going to try to make a point here. And it could just fail so miserably. So we're going to find out. I'm hoping to achieve an aha. That's what they call it in education, an aha moment where kids go, ah, yeah, we'll see. So if this were last night's homework, yesterday's work, and we went to graph this, what would be the first thing that we would do? We'd have to find A and B, and A is 2, and B is -4. And so if we're going to find the vertex, we have to do the opposite of B divided by 2A. What's the opposite of B? 4. Divided by 2 times A, which is 2 times 2, which is, and 4 divided by 4 is, okay, so we can now safely say that the vertex is at 1 something, right? And how are we going to find the something? Plug 1 back in. And so if I plug 1 back in place of x, follow the little yellow jelly bean here. If you put 1 right there in that little yellow jelly bean, what is 1 squared? What's 2 times 1? 2. So I have 2, and then it's going to, I believe, be just -4, right? And then -1. And what's 2 minus 4? What's -2 minus 1? Okay, so after all of that, and you're pretty good at that. I mean, admittedly, that was pretty easy. Comparatively, some of the ones that had like fractions, they took a lot longer than that because you got to do all the converting denominators or turning things into decimals. But this was pretty walk in the parky. So again, we're staying in yesterday mode. If I were to go graph this now, I would go to the point 1, -3, which is right 1, down 3, and I would put my dot. And what kind of modification would I place on my graph? Say it again. Right, I'm gonna stretch it by 2, right? So I'm still, remember, we always still go out 1 and do something. We should go out 2 and do something. That doesn't change. But if I go out 1, how far up should I go? Yeah, double 1 is 2. Good. And if I were to go out 2, how far up in this case would I go? 8, double 4. Good. So out 2, 1. Oops, that was just not supposed to be there. My bad. So I'm going to go out 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8, and then I would make a graph. I'm clearly going to run out of real estate at that point, right? Do you guys have any issues with that? So that's not what we're doing today. That's what we did yesterday. Now this is where I'm supposed to have my aha moment. And you don't have to politely say something like, ooh, that's neat. But it sure would be cool if you at least thought, ooh, that's neat. If you look back up in your notes, before we converted it and did all that stuff with multiplying and distribution, what was our original math problem? It was y equals what? Good. So at this point, if this 5 minutes has been even remotely well spent, I would like you to look at that vertex form equation and see if you can quite simply relate it right now to the graph. Just look at it. Forget all the math we've done and just look at that equation and look at the graph, see if you could make a connection. Think about the name. Remember, what's this form called? It's called vertex form. We certainly wouldn't call it that for just some random reason. What do you see, Brady? I agree. So I say to myself, and Brady has made the connection, let's ask ourselves a question here, a very simple question. Look at these parentheses. What X value could you put right there in place of X, right here where I'm circling? What number could you put in place of X to make the parentheses equal 0? A positive 1. And remember that our vertex was at the point positive 1 something. Now look at the back of the equation, and what do you see? I'm sorry, this is a rhetorical question. You don't have to answer it if you don't want to. What do you see at the end of the equation? A negative 3, which conveniently was also the y coordinate of our vertex. Do you see that? That's where he gets his name of vertex form. Is that, wait a second, so I could have just graphed it like that. I didn't have to go through all that stuff about multiplying it out and then doing negative b. Right, that's the whole point. And then you just use the first number as your builder. That's how easy vertex form is. It literally hands you the vertex on a silver platter and says, take it. You don't have to do any math at all. You almost can't mess this up. You don't have to do negative b over 2a and then plug some fraction in and square it. And then, oh my God. Yeah, here, it's on a platter. Take the vertex, plot it, use your builder number, you're done. Each problem should theoretically take, I don't know, 30 seconds. Right. And that's your x coordinate of your I know. I thought you might like that. And I apologize, half apologize to make you go through all of that to reach that moment, that epiphany, but I wanted you to see that it's legit. That's pretty cool that even when we worked it out and multiplied it out and did it the yesterday way, it's like, wow, hot dang, it still really is like it's the same thing. So what I want to do now is just put up a couple of equations in vertex form and let's practice graphing. And before I finish this, because the lecture now won't take long from here, before I finish, I want to say this. After today, we'll spend a couple of days with working, because you would say to yourself, like, man, I wish they all could be like this. That's what a normal person would say. It's like, I wish all the graphs were just like this. Well, we're going to spend a couple days making them all like this. And it's a rough little couple days where we convert standard form quadratics into vertex form, which is pretty cool. It's one of my favorite things to go through. So I'm going to put up an equation. Let me get rid of some. I'll just erase all this stuff. Maybe I'll erase, kill that, kill that, kill that, kill that. That one I can't get rid of, the old pesky booger. Maybe I can. Watch this. It's almost like he was never there. Take that, sucker. All right, let's do an equation. If the last 5 minutes serve the intended purpose, which I know from some body language and some things I heard for at least a few of you it did, then you already know how easy this is. What's the vertex, first of all? -3, +4. That is awesome. I don't have to do BA, divide, plug. Nope. So I just literally already have my vertex. So I'm just going to go left 3 and up 4. 1, 2, 3, 1, 2, 3, 4. Pop a dot. Holy Nikes, that's nice. Now, when we talk about structure, so I use this analogy when I say this, and I never know if anyone but me knows what this means. I always call all of this stuff the directions. I'll never write this again. The directions to the job site. And then I call this the blueprint on what you're supposed to do once you get there. So I think of it as I've already used all the directions to the job site. All that stuff with the parentheses and the squared and the thing at the end, I could at this point, without any damage, say, you've served your purpose. Thank you. All I need to do now is look at my builder, my blueprint number. And I get from that -1/2 a couple of things. First off, tell me about him, the graph. Gavin, this is for you. Tell me about that graph. Yeah, that's why I called on you there, bro. We know it's going to open down because of the negative, right? Yeah, Joe. And what else about the graph can we say? Yeah, so it's going to be a little bit of a mild fatty because of the half is going to shrink all your vertical jumps. And so it'll grow downwards half as quickly as it otherwise would. So when we go out 1, how far down do we go? A half of 1, which is a half. Good. When we go out 2, how far down do we go? Half of 4, which is 2. When we go out 3, how far down do we go? Half of 9, which is 4.5. Good for you. And we keep going and we keep going. And we go out 4, how far down would we go? And again, we could do more maybe, but that's the idea. That's how quick graphing can be when it's in vertex form. The vertex falls out just right in your lap, and then you go and build the thing. Nothing to it. Any questions about that? Okay. So the only other, just in case, I feel like to put a little closure on this, the only eventuality that you know, I always say it's an Ahern thing, and we're like, oh, I forgot to say this or that. I don't think you'll see any on today's worksheet, but if you did see something like this, is that in vertex form? Yeah. Again, it's hard. It's a tough sell if the only thing you know about vertex is the one with the parentheses. But just to make a case, like we did earlier, we could make the case that it's this. And then I think it's pretty obvious. Where's the vertex at? 0, -5. Very good. So down 1, 2, 3, 4, 5. And then what is the growth aspect? Like, does it open up or down? And skinny or fat? Skinny, because this fat. Skinny, fat. Yeah. So it's definitely skinny because the 2 causes a stretch. It pulls your Y's up quicker. And so when we go out 1, we'll actually go up double 1. And we go out 2, we'll go up, you know. Say again, buddy. Yeah, this, I can't, I wish when I erase them, it wouldn't erase my axis, but it does. So like, check it out. Like if I get rid of you saw me do this earlier. If I get rid of the dot, then, well, I lost mine. So sorry. That's why I switched colors for you there, Brohan. You guys have any questions about that? Easy peasy, huh? Vertex form is rad. So, all right. Everybody say bye really loud. Bye. That's pretty good.